Okay, so in the sequence of trigonometric ratio, looking at them as lengths, um, so we started with the unit circle, and we basically looked at how in a unit circle, right, this is 1, and so the opposite side actually becomes, I don't know the colors that I used, but okay, the opposite side in fact becomes sine theta, and the adjacent side becomes cos theta. Okay. And then if you draw a vertical line and so on, so you can get tan theta and secant theta and cot theta and cosecant theta, but I mean they are all similar triangles, and that's one way of looking at it and how we could have got it. But there's a much simpler explanation for it. So a simpler way of looking at it, you have the original triangle, you have 1, you have sine theta, you have cos theta, okay, and so I can, in this case this ratio was 1. I mean I can get similar triangles by multiplying and dividing it by anything. So I'm going to just divide it by sine theta. So if I divide everything by sine theta, so I get my hypotenuse. I remember this is all with this angle theta. Okay, so my hypotenuse simply becomes 1 by sine theta, right? So automatically the opposite side becomes 1, and this side becomes cos theta by sine theta, which is the triangle we have looked at, which is cot theta 1 and cosecant theta, which basically we remember as cot square theta plus 1 is cosecant square theta. This gives that. I'm sure I use that. Cot square theta plus 1 is cosecant square theta, right? So this is one kind of result that we have. Yeah. The other one is, the other triangle is if I use the same triangle and I divide all sides by cos theta instead of dividing them by sine theta. So then the hypotenuse will become 1 over cos theta. The opposite side will become sine theta divided by cos theta, and the adjacent side will become 1. Okay, well, anyway, so this is the triangle, which is 1 tan theta and secant square theta. So this is secant theta, this is tan theta, and this is 1. So of course in all these cases, in this case you have this triangle, you have this triangle and this triangle. Depending on what is given, you can always very easily use these three triangles to say, well, if this quantity is given as 50, then this is 50 tan theta. You scale the entire triangle, so this becomes 50 times tan theta, and this becomes 50 times secant theta. So that's the advantage. But all I wanted to show here was that you could just think of it as similar triangles and derive all this. You don't necessarily need to visualize that there has to be x equal to 1 and so on. This can be a way of final synthesis, that you can just get the triangles from each other as long as you know what the ratios are. You are still getting them as lengths, which means all the things we talked about on how to, once tan theta is a length, what will happen to tan theta as theta changes is equally valid. Only because we had a unit circle before, you could easily see that secant theta and cosecant theta are 1 or greater than 1. That was very obvious. That is not as obvious or clear now. That's all. I mean, here it's clear because 1 is here. That means the hypotenuse will always be greater than 1. Well, here also this is constant. This is 1. This angle is theta, so this angle will always be, hypotenuse will always be greater than 1. That's also a legitimate way of looking at it for the same results. So yeah, I mean, So it's kind of cute and cool that we could find this cool way of figuring out what tan theta and cot theta is, but you could simply get them by dividing the original triangle with sine theta or cos theta, and in a way that's what we do. But we do it in equations because we have the cos square theta plus sine square theta is 1. And then we divide the entire equation by cos square theta. So here I'm just dividing by cos theta and sine theta, and when I do the Pythagoras theorem, of course, I end up squaring it. So if I divide by sine square theta, then I get cot square theta result, cot square theta plus 1 is equal to cosecant square theta. And if I divide the same expression throughout by cos square theta, then I'll get 1 plus tan square theta is equal to secant square theta. Okay, maybe I could have used red because it's related to cos. So yeah, so we do this, and this is another way to look at it visually.